Welcome to GEL, GATE ESC lecture. We are in lecture 97 of EDC. This is your 7th module, that is a MOSFET. Now from this lecture video, we're going to do analysis on current and voltage terminologies which are associated with MOSFET. Okay, that means that we will going to find out the IDS formula in this lecture video. After find out the formula, we'll look and observe this formula. We will look and observe this formula, and we're going to analyze in next two videos. We're going to analyze how this formula works, how the behavior formula means what, the behavior of this current, yes or no. So how the behavior of this current will going to change in ohmic region and in saturation region. Okay, so in this lecture video we're going to find out this formula. In next two video lecture we're going to discuss about ohmic region and saturation region में ये formula का behavior कैसा होगा. Very important for a gate point of view, most of the cases. Okay, very important. Okay, now let's start with a simple thing. So this is a n-channel MOSFET. Why n-channel? Because we have formed a channel between n plus and n plus. We have formed a channel between n plus and n plus. That means this substrate is, I haven't drawn the substrate right now, but you can assume this. Okay, this is a p substrate, and in which this is your n channel. Yes or no? This is your n channel. Correct? This is your n channel and this is a p substrate. Now listen to this carefully. Voltage across this channel, we're going to talk about this channel only. Okay, इस channel के बारे में हम लोग बात करेंगे. Listen to this carefully. Voltage across this channel reduces from drain to source end, in this way. सर ड्रेन टू सोर्स वोल्टेज में कैसे रिड्यूस होता है? लुक, ये अगर आपका ग्राफ है वोल्टेज का और ये ग्राफ है आपका डिस्टेंस का चैनल में, चैनल लेंथ का, देन ड्रेन से सोर्स तक it reduces like this, somehow like this. You got this point? So voltage across this channel reduces in this manner. So that is why voltage across MOS capacitor given as VMOS equals to overdrive voltage, total overdrive voltage and minus channel voltage. So what is your channel voltage? So channel voltage यही है ना, channel voltage, ये channel length था और ये channel voltage था ना. हाँ, so channel voltage is Vx and overdrive voltage is your sir VGS minus VT. सर ये आपने बोला था सर overdrive voltage, सर तो voltage after which VT ये हुआ और VGS ये हुआ, तो VGS versus IDS, this is your transfer characteristics curve. After VT we used to get an overdrive voltage. So that means your overdrive voltage is your VGS minus VT, sir. So VMOS will become VGS minus VT, yes or no, minus V of X. Remember this formula. Okay, remember this formula. We are going into another zone. Look here, now we are going to find out IDS. We know current is nothing but dq by dt, and in place of dq by dt I can write down dq by dx into dx by dt. I just divided a dx and multiplied a dx. Now we know this dx is nothing but dx by dt is nothing but your drift velocity, and as this is a n channel MOSFET I can write it down. Drift velocity is nothing but minus mu what? सर माइनस म्यू एन इंटू ई एक्स. सर हाँ सर नेगेटिव क्यों आया है? अरे इन ड्रिफ्ट वेलोसिटी वाला लेक्चर वीडियो में, इफ़ यू रिमेंबर इन लेक्चर नंबर 4 I have discussed for positive charge particle Vd is plus mu e, for negative charge particle the drift velocity is minus mu e. So this negative is because of electron moving direction is opposite to the direction of electric field. I have already told you in a fourth lecture video. Okay. So that is why this negative charge is. So I can write down this expression, that is dq by dx into minus mu n into ex. Okay. Now I need to go for, so to find out IDS value, I need to look for dq by dx value. Okay, so before getting to dq by dx, there is another thing I'd like to share with you. We have studied Cg equals to, in previous video lecture, we have studied Cg equals to, if cyclone W into L by T naught x. In previous lecture we have discussed C naught x is nothing but Cg by W into L. Correct? Now here you can see, now let's find out dq by dx value. The value of dq, after putting the value of dq by dx, we'll get the IDS value. Now let's find out the dq by dx value. Dq by dx will, how are you going to find out dq by dx value? Look, how are you going to find out dq by dx value? Q equals to CV. We know this? Huh, sir? So in place of C, here is C means CG, V means VMOS. Yes or no? Huh, sir? So in place of CG, I can write down C naught X into WL. Oh, C naught X into WL. अच्छा सर, हाँ सर, हम लिख सकते हैं सर. In place of CG, I can write down C naught X into WL. लिख सकते हैं? हाँ सर. Into VMOS लिख सकते हैं? हाँ सर, VMOS है. सर VMOS का वैल्यू यही है ना? यही है ना VMOS का वैल्यू? हाँ, यही वैल्यू है. So if you look here, you got Q equals to C naught X into W into VMOS into L. So instead of writing L, I can write down dx for dq. If Q value is into L, so थोड़ा सा चैनल लेंथ के लिए थोड़ा चार्ज रहेगा. अंडरस्टैंड? हम पूरे चैनल के लिए ये वैल्यू निकाल रहे थे. अब अगर थोड़ा सा चार्ज के बारे में बात करेंगे तो दैट मीन्स दैट विल बी दैट वी आर कंसिडरिंग थोड़ा सा चैनल. इन प्लेस ऑफ एल आई एम राइटिंग डाउन dx because for dq it would be dx. Yes or no? Yes sir. So I can say that means dq by dx is equals to C naught x into W into VMOS. Okay, now here by putting this value in here, okay, dq by dx का वैल्यू मिल गया हम लोगों को. By putting this value here in this expression, you'll get a IDS value. Look here carefully. You'll get IDS, which is nothing but mu n C naught x W divided by L whole into VGS minus VT into VDS minus VDS square by 2. Got this point? You'll get this value of IDS. Now in the next two video lecture, I'm going to discuss with you a very, very, very important point. What are those important points? How this IDS current, how this current is behaving in this saturation, in this ohmic region, and in this saturation region. How this expression is changing and what are the node points. Okay, please remember, extremely important for GATE and engineering service exam point of view, and do watch these two video lectures for ohmic and saturation region. Thank you so much for watching this video. Okay, do watch your next video lecture. Till then, bye.